Okay, so as in the last video, we have discussed molarity in very detail, alright, which was the second last term, concentration term related to the volume, which would of course be affected by the temperature since this is related to volume, and anything which is related to volume would be affected by temperature. If temperature increased, the volume will be increased. If we decrease the temperature, the volume will be decreased as well. Since volume is directly proportional to the temperature, this equation was given by Charles and Charles law, right? So in today's video, we are gonna discuss, or we're gonna learn our last concentration term, which is of course related to the volume. Then we're gonna move towards the concentration terms which are related to the mass. Here we are completing first the concentration terms which are actually related to the volume. Alright, so today we are going to discuss our fourth, which is of course the last concentration term related to the volume, and that is normality. In the last video we discussed molarity, right? Molarity was nothing but it was number of moles divided by volume. As the molarity, as the term suggests itself, there would be involvement of moles. So as that was related to the volume, so that's why number of moles per unit volume. And how to find number of moles? Number of mole is equal to given mass per molar mass, or if you are given the volume of the solute, then you divide that volume by molar volume, which is 22.4 dm3, and you of course will gonna get the number of moles of the solute then. But in today's video we are going to discuss normality. Right? Now see, to understand normality, initially we need to understand equivalent mass, which is very important topic, right? So initially we're gonna learn equivalent mass, right? Equivalent mass. Now see, equivalent mass of something is equal to the molar mass right per unit x. Now see, what does x represent here, right? Initially this is the formula for finding the equivalent mass of anything. You can find equivalent mass of NaOH, you can find equivalent mass of H2SO4, you can find equivalent mass of NaCl, you can find equivalent mass of anything, right? So for now, the formula for finding the equivalent mass of any substances, you need to take molar mass of it and divide by the x. X is the valency factor here. X is the valency factor. Now see, we will gonna discuss this x in three terms. Initially, we will discuss this x for acids, then we'll discuss this x term for bases, alkali, right? And then we'll discuss this for salt. We must discuss this for elements as well, so that everything must be clear to us, right? In the case of acid, if you have acid, right, if you have H2SO4, which is of course acid, right? H2SO4 is sulfuric acid. In the acids, the X factor would be number of H ions produced by the acid. Number of H ions produced by an acid. Now see, what's the formula for equivalent mass? Molar mass. Equivalent mass is equal to molar mass per unit X factor, right? So molar mass of H2SO4. Now see, H2 means 2 plus sulfur has a mass of 32 and oxygen has mass of 16. So 16 into 4, right? this would be equal to, right, 98. So 98 is the molar mass of it. And as I told you, X will gonna represent here the number of H ions present in the acid. So here H ions are 2, right? So 92 divided by 2, which is of course 49. So 49 is the equivalent mass of H2SO4, right? Now you see how we find the equivalent mass. Molar mass of that substance per unit X. X is the valency factor, which is described for 4 terms. 4 acids, this X will gonna represent the number of H ions produced by an acid. 4 base now, this X represents the number of OH ions produced by the base. So here we are going to take an example of base, which is NaOH. Now here this X factor will going to represent number of OH ions produced by this NaOH base. Now see what we have a formula, molar mass per unit X factor. X factor here in the base represents OH ions produced by the base. So molar mass of NaOH is of course 40 gram, right? So 40 per unit. OH ions, here are only one, right? One OH ion only. So 40 divided by 1 is 40. So 40 gram is the equivalent mass of NaOH. Now let's come towards salts. For salts, this X would gonna be represented for the number of positive charge on the salt. Now see, if I do take an example of salt, which is NaCl, right? NaCl is the salt. Here we have positive 1 charge, here we have negative 1 charge. But this X for salts will gonna represent the number of positive charge, which means we need only this, right? You can take example of AgCl2, you can take any example, right? So for this, molar mass per unit X here represents number of positive charge for salts. So NaCl has 58.5 mass, right? And X is here 1, of course. So the equivalent mass for it is 58.5 gram, right? Now let's talk about the elements. What X will gonna represent for elements? For elements, X will be the valency of an element, right? Now see, if I have an element, for example O, right? So now how will we gonna find the equivalent mass of it? Molar mass per unit X factor. X factor will gonna represent here the valency of it, right? Valency. So molar mass of oxygen is 16 gram, right? X is here valency of oxygen, and valency of oxygen is 2. So this is 8 gram. See, we have -2 valency, we have -2, we know that. Okay, so we have actually found the molar mass, the equivalent mass of it. Now see, molar mass divided by X is the valency factor. We have found the formula for equivalent mass, and this we have discussed in very detail, right? The X factor for acids, it will gonna represent the number of H ions produced by the acid. For bases, the X will gonna represent the number of OH ions produced by that base. For salts, the X will gonna represent the number of positive charge in the salt. And for elements, the X will be the valency of that element. Okay, so now see, now we need to find number of gram equivalent mass. Gram equivalent mass. How do you find number of gram equivalent mass? Here you have found equivalent mass. Now number of gram equivalent mass. Gram atom is actually mole, right? So we need to find number of gram equivalent mass. How will you gonna find that? The formula for finding the number of gram equivalent mass is molar mass divided by equivalent mass. And how do you find equivalent mass? Molar mass by valency factor x, right? Now what's the formula for finding the normality? Now we can actually find it, right? So for finding the normality, the formula is number of gram equivalent mass per unit volume. Since this is related to volume, right? Volume of solution in liter. In liter. And this is of solute, of course. Now see, what's the formula for normality? The number of gram equivalent mass of solute per unit volume of solution in liter. And how do we find number of gram equivalent mass? Molar mass per unit equivalent mass. And how do you find equivalent mass? Molar mass by x factor, which is the valency factor. And x is again defined for these four terms separately, right? So normality, now see, we must discuss some basic terms as we discuss here, right? Molar, semimolar, bimolar, trimolar, decimolar, centimolar. We have here these terms too. We have normal, which is of course denoted by capital N, right? So this is capital N. 1 capital N, right? We have binormal. Bi basically represents 2. So this is 2n, which means normality is 2. Trinormal, which means normality is 3. So 3n. We have decinormal, which means the normality is 10th part, n by 10, right? Or 0.1 n. We have centinormal, which is 100th part, 1 upon 100, which is equal to 1 upon 110, which is equal to of course 0.01. So that it will move, so 10 power minus 2, right? Normal. So if you have a normal solution, that is 1n, binormal, normality is 2, trinormal, normality is 3, decinormal, normality is 1 by 10 or 0.1, centinormal, normality is 1 by 100 or 0.01 normal. Okay, so here in today's video we discussed normality in very detail. We actually discussed 3 very important formulas: the equivalent mass, which is equal to molar mass by x, x is the valency factor, which is defined for all the 4 of the terms: acids, base, salts and elements, right? Then we discuss number of gram equivalent mass, which is equal to molar mass by equivalent mass. Then we discuss normality. Normality is equal to number of gram equivalent mass of the solute per unit volume of solution in liter. In next video we will gonna start now the concentration terms related to the mass, since we have completed now the concentration terms related to the volume.